Good afternoon, everyone, and welcome to another virtual tour of outer space. My name is Josh. I'm from the Morrison Planetarium at the California Academy of Sciences, and we are coming to you at your house to do a very special program where I get to take you on a tour of our solar system, the surrounding neighborhood for our sun, and you get to tell me where we are going. But I wanted to start us off with something a little different. We have a couple people watching already. If you have a location here on planet Earth you are from, you want to tell us about it, by all means, let us know where you are tuning in from. We're also going to take some time looking at a couple spots here on planet Earth using a software we use in our planetarium and actually used in planetariums across the country. This is OpenSpace. Now, OpenSpace isn't just a software for planetariums. It's a software for computers. And if you have a computer in your house and you want to try out OpenSpace, I would encourage you to do so. You can find out more on the OpenSpaceProject.com. It's a really cool place for you to download and find out a little bit more about the OpenSpace software. Now, you can actually see it in this little inset window. Our producer, Bing, has put it up on the side there. I'm going to fly us in just a bit towards the planet we've been circling for the past few minutes. This is planet Earth. And as we dive into planet Earth, we get to see some really cool stuff going on the surface. Now, as we get closer and closer, you're going to see the image change. You're going to see new stuff popping up way down here. You'll notice it looks like someone chopped a big piece of the clouds out. That's because we are seeing the map actually transition. When we get very close, we can pull in satellite imagery taken of planet Earth over time, and that satellite imagery was taken at different times, sometimes days, weeks, or months apart, and you can see a little bit of change between one side and the other. That's the case right here, where we have one low-resolution part of the San Francisco Peninsula and another slightly higher resolution part right next to it. But as we get closer and closer, depending on how fast my internet is, we should see more of the surface become visible. And as we do so, you'll actually be able to see this greenish bar right here is Golden Gate Park. As we get closer and closer and closer, you can see our museum should be right around here somewhere. And as that pops in, there we go, you can see our green living roof. Now, I haven't been to the museum in a while, many months. I miss it a lot. I know many of you do too. Looking at places here on Earth in this software might not have been what people first intended planetarium software to do, but it's really nice. Right now, when a lot of us are stuck in our houses, being able to travel anywhere on Earth and see all sorts of cool stuff is a pretty wonderful thing to do. So right now, you're looking from Golden Gate Park towards the Marin Headlands up here. You can pan around and see the rest of our city downtown over this direction. Now, being able to see the surface of planet Earth, all those mountains, you can actually see Mount Diablo, I think, over there in the East Bay. This lets us see our planet in a really special, really awesome way. Looks like we've got folks tuning in from all over California, as well as from Connecticut, from Jamaica. This is a pretty good spread. We have folks all over planet Earth tuning in to watch our broadcast. I would love for all of you to give yourselves a chance to do some sightseeing here on planet Earth using OpenSpace. And if you take a cool screenshot or image, share it with us. Let us know what kind of stuff you spot here on planet Earth. But as we zoom back, you can see another really cool factor of this software. When we look at those photos of Golden Gate Park or San Francisco, those could be photos that were taken weeks or months ago, depending on when a high-resolution satellite last snapped a shot. But for the big general images of planet Earth, we're actually seeing clouds as they were yesterday. So you can see some parts of California are cloudy, some parts aren't. The part I was in was cloudy. But if it's not a cloudy night for you, I would suggest going out and seeing a comet that should still be visible in our sky. That's Comet Neowise, and that is an object that is just passing through our part of the solar system before it heads back out, and it won't be back again for several thousand years. So this is our best time to catch it, and boy, is it a comet. Now, if you've got a spot in our solar system you would like to visit, maybe one of the less transitory objects, something like a planet or our star, let me know. I love suggestions. If there's any place you think would be really cool to visit, let's go see it. Now, for checking out mountainy features, we could spend a lot of time on Earth, but I actually would like to take us to our next door neighbor planet, Mars, because Mars has some pretty exceptional mountains. Now, flying to Mars would normally take months. about 6 months for a human-safe spacecraft to blast off and get us to Mars. That's actually one of the mission objectives for Artemis, an upcoming set of missions from NASA. And if you want to find out more about Artemis, we have an upcoming cosmic conversation you should be able to check out with the Artemis team. And we will have the date for that posted on our website in just a little bit here on our Facebook page. If you're not tuning in from the Facebook page, if you're checking us out via YouTube, that's awesome. We're very glad to be sent out through OpenSpace, but you can also check us out on Facebook under the Morrison Planetarium. Now, we've got a lot of cool stuff happening in our cosmic conversations, but this is one I am especially looking forward to because we are going to find out about the upcoming missions and where they want to go on the moon and on Mars. Mars poses a really awesome challenge for humans. It's another planet and not one we are good at living on. So we might want to practice on the moon for a little bit before we set off to Mars. Sounds like Charon had a cool suggestion, something we don't often get suggested, Uranus. Now Uranus, when we zoom back, sorry, that was a bit of an extreme flight. We're going to go see something that looks totally different than Earth or Mars. Just based solely on color, you might think Uranus was a better match for Earth because of that beautiful blue shade. But there's something missing. When you look around the surface of Uranus, you're not going to see any mountains or valleys or hills or craters or oceans or bays. There's no surface features, because we're really not seeing a surface. We're seeing the top layers of its clouds, like that big white thing right there. Now, the clouds change. You can see a dark cloud over here and a yellowy patch right here, and they do fluctuate over time. But what we're really looking at is the top of a very different kind of planet. Saying that all planets are similar because they're round is like saying that all mammals are similar because they've got 4 legs and a head. That's coarsely true, but there's a lot of variation in them. When you look at the surface of Uranus, we are seeing that outer atmospheric layer, but it's not like there's land underneath that. Underneath that, we probably have something similar to, if you ever get those drinks from a convenience store, a Slurpee or an Icy, it's going to have a icy slush with a thick fluid suspended within it. Now, landing on the surface might be sort of possible. If you sink through those clouds until you have something about the same density as your spaceship, you'd just come to a rest on that slushy pile. That would be very different than landing on planet Earth, but maybe kind of a cool thing to check out. Some folks ask about the diamond bergs inside there. There is a possibility that we've got big chunks of carbon floating around, but I would be hesitant to call those diamonds. Diamonds are a very specific configuration, and this is probably more like a graphite blob. Ooh, checking out Pluto sounds like a great idea. Thank you, Laura. You've given us some great suggestions in the past. Pluto, I always love checking out. I could spend so much time looking at Pluto. It is just a super cool object that I almost called a planet. Is Pluto a planet? What do you think? Let us know in the comments. We can vote yay or nay. Is Pluto a planet? I'll tell you my personal thoughts. When we look at Pluto, we are seeing something that used to be classified as a planet, is not classified as a major planet, and is classified as a dwarf planet according to the International Union of Astronomers, the IAU in America. When you look at the surface of Pluto, it's very different than what we've seen before. It's not quite like Earth. It's also not like Uranus. It's got something different still. It's an icy surface, so maybe you could say it's a little bit like Mars in that it's got a very little atmosphere, but it does have some. It's got rifts and valleys, cracks and craters, but they're not forming in rock like they do on Mars. What we're seeing here is an ice surface where the surface is covered in water ice. Now, does that mean that it was once a giant ocean that froze? Probably not. What it probably means is that ice out here is barely ever a liquid. It's pretty much a solid. Now, on Earth, that's kind of a weird thing to say because we have solid rock and liquid water. But think about if Earth was a lot closer to the sun, our water would probably turn to a gas. We'd have gaseous hydrogen and oxygen floating around, and our rock might actually melt, turning to a liquid. So we'd have gaseous water and liquid rock. When we think about the substance that something's made of, we also often think about a temperature. Temperature can change a lot, though, in different places in our solar system. So what's a gas on one world might be a liquid on another, or a solid on one even farther out. For example, take a deep breath for me. Big inhalation, pull a lot of air into your lungs. When you did, most of that air wasn't oxygen, it was nitrogen. Now, nitrogen, way out here, isn't a gas. It's not something you could breathe in, at least not easily. But it is a semi-liquid. Check out this goopy stuff. Way down on the surface of Pluto, you can see between these mountains is this giant flat plain. Now, this is probably a sea of nitrogen. Same stuff we just breathed in, but out here it is so cold that it's turned into a goopy fluid, kind of like toothpaste. You can see warm spots rising up, causing what we call convection cells, where there's kind of bubbles of stuff reaching up to the surface. If you want to see a similar pattern, we could look at the sun, where hydrogen is doing that same convection. Or you could look at the top of a pot of boiling water, where boiling water is doing that convection. Hot stuff coming up, cold stuff sinking down. So the surface of Pluto is super cool, but this wasn't just a request for Pluto. This was also a request for some of its moons. Now, how many moons does Pluto have? We knew of one a long time ago. That was Charon. Charon's kind of its primary moon, but again, kind of like Pluto, I have a hard time calling Charon a moon. Is it a dwarf planet? No. Is it a planet? Also no. Pluto could be called its companion, though. That would make them sort of a binary, a couple in space. They orbit each other. That's kind of a weird thought, but if you hung out on the surface of Charon, looking towards Pluto, you would never really see Pluto move in the sky. It would always be hanging out in pretty much the exact same spot. Stars around it would change and move over time, but it would hang out in the exact same place, and it wouldn't spin with respect to you. They're locked together, so the same part of Charon always faces Pluto, the same part of Pluto always faces Charon. These are two peas in a pod. They're also very close in terms of size. While Pluto is definitely bigger, it's not a whole lot bigger. When you compare moons and planets in our solar system, usually the planet is way bigger than the moon. Kind of like people and cars. There are big people and small cars, but generally a car is a lot bigger than a person. Well, when you start looking at the very small planets, they also tend to have very small moons. Mars, for example, just has two little asteroids, Phobos and Deimos. But when you look at Earth and our moon is actually fairly large. Kind of like Pluto and Charon, it's much bigger than we would expect a small rocky planet like Earth to have. That is pretty cool. Now, there are 4 other moons traveling around Pluto: Nix, Hydra, and 2 more whose names are currently eluding me. I think Charybdis might be one, but they're generally named after monsters from Greek mythology. So Bing's on the back end. I'm sure he'd be happy to include the names of the moons I'm missing, but there should be 5 moons traveling around Pluto. Now, 5 is a pretty cool number. When we look at the other planets, I should say planets of the solar system, not other, no one else, to my knowledge, has 5. Mars has 2, Earth has 1, Jupiter and Saturn have tons, and we're looking at the under 20, but still quite a few, for, Charybdis, for the 3-headed dog, and Hydra. Okay, let's head elsewhere. We had a couple other suggestions pop up earlier, but in the meantime, I want to take us to Jupiter to see some of those really big moons. So heading out to Jupiter, when we get there, you might be able to spot some of the moons by yourself without my assistance, because those moons are so big. 4 of the moons of Jupiter, called the Galilean moons, are just absolutely huge, like planets themselves. If I get us back far enough, you can see where those 4 moons are orbiting. And if you point a telescope to Jupiter, a medium-sized telescope at least, maybe bigger than 4 inches across, you should see a couple of those moons flying around. Now, observing those moons is a really cool thing to do. And if you wait long enough, sometimes you'll actually see a weird black dot appear on the surface of Jupiter. What we're seeing is one of the moon's shadows falling on Jupiter. And if you were floating in the clouds of Jupiter, because you couldn't really land on Jupiter, but you could float there, you would get a solar eclipse from that spot. Now, the spot's pretty small, and it would only do a little tiny pass across the surface of Jupiter, but it might be worth it, because if you were on the surface of Jupiter, those moons would pass by pretty frequently. The moons of Jupiter travel around Jupiter once every few hours for the closer ones, and I think every few days for the farther out ones. So you'd be getting those solar eclipses all the time. Now, that sounds, I think, pretty awesome. I kind of hope one day human beings do get to go float around in the clouds of Jupiter for those solar eclipses and to study one of the most interesting planets in our solar system. Jupiter's always changing. It's got tons and tons of moons, and it's actually part of a family of gas giant planets that seems to be very common beyond our solar system. So the better we understand Jupiter and what it's like, the better we understand this giant family of planets, pardon the pun, giant family of giant planets, we will have a better understanding of planets as a whole, as well as the interesting boundary between a planet and a star. Because if Jupiter was 16 times bigger than it is, but still made of the same stuff, we would have 2 stars in our solar system. So again, I'm looking for suggestions. If any of you have a cool thing you would like to check out, throw it in the comments, and we will do our very best to go visit. But right now, since no one's thrown anything in, I'm going to go visit something else I think is super cool. I want to take us to one of these moons. So zooming in just a bit, I've had very bad luck with Jupiter's moons. The bad luck continues. We get a featureless gray ball where Europa is supposed to be. We could try another one real fast. Let's try Io. Now, Io is also a fun one to visit because Io looks like a pizza, kind of a gross pizza. Looking at it up close, you can see this mottled yellow and red with whitish streaks on it. What we're actually seeing is an incredibly active volcanic surface. There are hundreds of active volcanoes on Io at any given moment. Given the size of this body, it has a huge amount of active volcanoes per unit area, making it kind of an exceptional thing in our solar system. Ooh, Shannon wants to check out Venus. Good segue. We see a ton of active volcanoes on the surface of Io, and we have only just recently, I saw a paper yesterday talking about the potential discovery for a ring of fire, an active specific region on the surface of Venus. Now, my Venusian geography is not that great. I will do my best to point out where I think it is, but if you folks are interested, go look this up. Active volcanoes on Venus. This is some breaking scientific content and a really cool thing to see. For a long time, we've suspected Venus would have volcanoes. We saw things that look like volcanoes, and we suspected some activity, but this is way more than we thought, way more widespread than we thought. And now that we know what we're looking for, fairly obvious activity on the surface of Venus. Now, we've long said Earth is the only geologically active planet in our solar system. That's coarsely true. When we talk about activity, we usually want to see things like volcanoes, subduction zones where rock is moving around on the surface. We don't see a ton of activity on the surface of Venus, but we do now see some. Understanding what's powering it, its longevity, the amount of material being moved, all of these things will give us a much better understanding of what's going on inside Venus. Now, when we see these volcanoes, Megan wants to know if they explode, shooting out stuff like volcanoes do here on Earth. Some volcanoes on Earth definitely do. You've seen video of stuff like Mount St. Helens erupting with that huge explosion. Other volcanoes kind of ooze lava, either quickly or slowly, depending on the kind of rock the volcano is shooting out. When you look at the volcanoes on Venus, we have seen, I believe, a couple small cone volcanoes, but I don't think those are the ones that are showing activity. If I recall correctly from the paper, the ones that we're seeing show activity probably are more oozers. They're very flat volcanoes called pancake volcanoes, and they dribble lava, not quite that same explosive eruption. But I would want to double check that, Megan, so I will go look at it. Oh, okay, how about Saturn's rings? We're talking about an interesting segue here, but One of the theories for Saturn is that those rings might actually be icy particles shot off one of its moons. At least for some of the rings, there's some evidence to suggest that Europa may have sprayed some material out, or excuse me, Enceladus may have sprayed some material out and contributed to some of the rings. Now, we think that's plausible because of what those beautiful rings are made of. They look like they're a solid single feature, but what they actually are tiny particles of ice. For a long time, there's been a debate, are they rock or are they ice? But when we're looking at this, we're actually leaning more toward the ice line of reasoning these days. Part of that's because of their reflectiveness. When you look at how bright they are, it is kind of staggering. And you can see that without sunlight falling on them, they're pretty dim, pretty dark. You can see right behind Saturn, right there, kind of those much less vibrant rings. Now, because of that reflectivity, they had to be light-colored material, something that bounces a lot of light. Ice would certainly do that, but there are some kinds of rock that would do it too. The idea that they're being replenished by one of Saturn's moons gives us more credibility to the ice side of the argument, but really we owe a huge amount to the Cassini mission. I'm wearing my Cassini farewell mission t-shirt today, so I'm feeling a little bit melancholy. But Cassini explored Saturn for years and years and years. It taught us so much about not only the rings of Saturn, but its moons. It taught us about the cloud composition and the changes on the surface of Saturn. Cassini has to be one of my absolute favorite missions. There was also the Huygens probe that visited the surface of Neptune, the surface of Titan, really cool stuff. Tracy wants to see Neptune though, and since we visited Uranus, we always kind of have to go see Neptune. That's sort of a package deal. Neptune is beautiful. We're flying on out, and as we do, think about Uranus. When we first saw it, what struck you? That kind of robin's egg blue color? Check out Neptune. This is not robin's egg blue. This has that beautiful, dark, purpley, vibrant blue. It's got similar features. You can see a light cloud down here and a darkish spot. But this is not a cloud, or at least I'm guessing it's not a cloud. I would offer the guess that this is a storm. Now, we see low-pressure storms on Neptune, and those low-pressure storms can have that swirly aspect, a lot like the Great Red Spot on Jupiter, but these things don't seem to have quite the same longevity. Maybe it's because when we're looking at Jupiter, there's a huge amount of gas that makes up the planet and no solid surface. On Earth, hurricanes lose energy when they go over land. They gain energy when they're over water. Here, there's a little bit less energy pumping into the system, so the storms never quite reach the same scale as the Great Red Spot. They probably don't last as long either. However, we don't spend much time studying the outer solar system. Why are the gas giants called it? Are they balls of gas? Mostly, yeah. They're made mostly of something that we call a gas here on Earth, which is hydrogen. So things that are made mostly of hydrogen we're calling gas giants, except if they're a star. When you've got a big gaseous world like Jupiter or like Saturn, we have gas on the outside. It then gets a little denser underneath, and the gas gets compressed to the point where it would form a liquid. It'd still be made of hydrogen, so we'd get liquid hydrogen. Underneath that, there's even more pressure, even more squeezing. We think the hydrogen actually becomes a solid. So when something is solid and hydrogen, it acts like a metal. You can actually hand electrons back and forth, atom to atom, and Jupiter actually generates a huge magnetic field because of that. Okay, now let's try this out. We wanted to see the rings of Saturn one more time. Jupiter has rings too, just not nearly as impressive rings as Saturn. Why haven't those rings formed a planet? You're asking a perfect question, just kind of backwards. When we talk about the structure here, probably was a moon at one point that became rings. Because that moon got a little bit too close to Saturn, it passed within what's called, I believe, the Roche limit, and experienced something like a gravitational stretching, where one part of it got pulled a little bit more intensely by the gravitational tug of Saturn, and that part got pulled towards Saturn a bit, and a part that's farther away doesn't experience quite as strong a tug, and the whole object gets pulled apart basically shredded over time, those pieces keep bumping into each other and grinding each other down, forming effectively a thin disk of material where objects are smashing into each other, grinding themselves finer and finer, and becoming those beautiful rings. There might be some clumping that happens within it. When two particles collide at just the right speed, they might stick together and get larger, giving themselves the potential to pull in more stuff and get bigger and bigger. The problem is they're also not going to be stable for that long. We think that those rings are falling into Saturn, and over time they will eventually disappear slowly, probably millions and millions of years, but they are in the process of disappearing, not forming another object. Looks like we got some more questions popping up. Megan is a natural-born scientist, wants to know, how the heck do we know Jupiter's a gas giant if we never landed on it? You can't land on it because it's a gas giant, but we did actually drop a probe into it. The Galileo mission headed out to Jupiter, spent some time orbiting around it, and dropped a probe down into it. And as it went deeper and deeper, sent back signals to the orbiting spacecraft and helped us understand that it is a gaseous envelope wrapped around it. And currently we have another mission called Juno in orbit around Jupiter, examining it. We do know its inner structure is made of gas, and we're trying to understand the part underneath the gas, that transition to liquid or to solid hydrogen, a little bit better. Now, sending something out to these has actually proven to be very scientifically beneficial. One of the coolest results from Jupiter, from the Galileo mission, showed us that there's a specific amount of hydrogen to deuterium. Now, hydrogen is one proton. If you've got a proton and a neutron, we call it deuterium. And when you've got just the right amount of hydrogen compared to just the right amount of deuterium, you can actually show what conditions in the universe were like when Jupiter formed. Now, we think Jupiter's just a tiny bit older than planet Earth, probably around 4.6 billion years old. And it shows us that the rate of hydrogen to deuterium in the universe has been changing in a predictable way. That's actually one of the coolest arguments in support of the Big Bang Theory, and we learned it here in our own solar system by diving into Jupiter. It's one of the coolest parts of astronomy, really any science. The more time you spend focusing on something and learning as much as you can about it, the better you understand that thing overall. When we look at our sun, at our solar system, it might seem like kind of a trivial thing to be spending so much time studying, spending so much time trying to learn about, but it really isn't. Stars are important in our universe. Our star is the most important to us because we're in orbit around it. But when you look at all those other stars in the sky, each one of them is doing the same fundamental processes as our sun. And that's just the ones we can see in our galaxy. There are tons and tons of other galaxies out there, each made of their own stars. Around those stars, we are discovering planets. We call them extrasolar or exoplanets, and they have to be the coolest thing in astronomy today. All these blue circles are showing you planets we have found around other stars. Some of these solar systems contain more than one planet. When you add all this up, we can't study those planets yet, but we can study the planets that are in orbit around our sun. And by learning more and more about them, we better understand planets as a whole. Any one of these might teach us something truly wonderful and profound about the universe, like Jupiter did, but we have to really understand it and the context, the place it exists within, to get those results. So that's why science is such a really cool process, and it begins and ends with things like our star. We learned so much about physics by studying our sun, learning what we could about it, and fundamentally uncovering the atomic processes that power it, something we call fusion. Sticking together little bits of hydrogen to make helium is the process that makes our sun shine, gives us so much energy. And since we have a beautiful sunny day here on planet Earth, for those of you who are still on the sunlit side, I would encourage all of you to go outside, point your face towards the sun, feel that sunlight hitting you right on your face, and remind yourself that you are feeling radiant energy that was released 93 million miles away from us and is just now reaching us on our skin and making us feel warm. that is a pretty awesome connection to the universe we live in. I can't think of anything better to end our show with. Thank you all for those wonderful questions and ideas about places to explore. Every single week is something new, something different, and we really have you to thank. If you folks are interested in finding out more about the night sky and the stuff we can see from planet Earth, tune in tomorrow where Bing Kwok is going to be taking us on a tour of the night sky, giving us a night sky update. On Friday, we will be speaking to our own Engineer Supreme Dantel, who's going to be giving us our cosmic conversation and telling us a little bit about the software we use in our planetarium and how he makes such cool things for it. Come next week on Tuesday, we're going to have Mary Holt taking us on a kids program at 9:30 Tuesday morning. So make sure you check out that time slot as well. From me and the rest of the Morrison team, thank you so much for tuning in, for letting us join you at your house and share some of our fun programming. Big shout out to Becca and family. Thanks for tuning in. If you have any questions that you came up with, or maybe a little bit too late, just write them in the comments. We will come back through and answer as many questions as we can. But from my house and our planetarium to you, thank you for joining us. Keep looking up. Have a wonderful day.